Rather than ignoring treatment heterogeneity and simply reporting the average treatment effect, we may actually want to explore it after we have conducted our experiment or after we have collected our observational data. Now, let us start with the simplest case, namely cross-sectional data. So we only have variation between subjects in our study, and there's no time dimension here. So we're not dealing with panel data yet. It's saying now that what we want to explore is whether the treatment effect varies by a certain pre-treatment condition for each subject, I, and let's call that high. So, and high is 1 if this pre-treatment level is high, and it is 0 otherwise. If we're going to interact the treatment dummy with this term high, then we have to make sure that we include all consecutive terms. So we also need to include high itself. So there's the treatment dummy T, there's the interactor treatment dummy T times high, and there's this term high. So how does it work? We start with the simplest estimation equation possible based on RCT. Simply only this alpha 1 times T with alpha 1 showing the average treatment effect. Now if we're going to interact the treatment with this binary interaction term high, then the estimation equation is going to look as follows. Additional terms are these alpha 2 times T times high plus alpha 3 times high. So that is the that allows for a different intercept actually, and the first one allows for a different slope. The alpha 2 shows whether the treatment effect is different for people in the high group relative to the people in the high is 0 group. This is the so-called fully interacted model. Let me actually show you graphically why it is important to include this alpha 3 times high term. What we have here is an example taken from Bramber, Clark, and Golder. And on the horizontal axis we have T, the treatment. The treatment actually in this case takes on values between 0 and 3. On the vertical axis is the value of the outcome, and that varies between 0 and 10. Right? So we have two sets of observations. We have observations for the high is 0 group. Those are the small circles here. And you can see that for this group, the treatment doesn't do anything. Right? So whatever the treatment, whatever value the treatment takes on, the outcome is always like 2 to 3 for this group. Well, we also have observations for the high is 1 group. Those are those small pluses, and we see that their outcome does depend on the value of T. Right, so the treatment seems to be doing for this group something from this group. Now, if we exclude alpha 3 times high, so if we forget to allow for a difference in the intercept, then we are going to estimate the thin line, right? So we force the same intercept on the two groups, and obviously you don't get the correct answer. So you don't get a correct estimate of the treatment effect for the high is 0 group versus the high is 1 group. Only when we allow the slope or the intercept to be different can we estimate the two correct slopes. One slope for the high is 1 group, alpha 1 plus alpha 2, and the slope for the high is 0 group, alpha 1. So never forget to include all consecutive terms when interacting your treatment dummy. Now, what is actually the effect of the treatment when we allow for this interaction? Here is the estimation equation at the top. So, well, the effect of the treatment is basically the marginal effect. So we take the first derivative to T, So if we do that, so dou y, dou t, then looking at the estimation equation, the terms that remain are alpha 1 plus alpha 2 times high. So what's new here is that indeed the effect of the treatment now depends on the value of high. And in this simple case of a binary interaction term, the treatment effect can be either alpha 1 when high is 0. So that's the conditional average treatment effect when high is 0 for the baseline group. And we also have a conditional average treatment effect for the high is 1 group, which is equal to alpha 1 plus alpha 2 times 1, i.e. alpha 1 plus alpha 2. Alpha 2 is the interaction effect here, and it shows you the difference in the effect of the treatment for the high is 1 group relative to the high is 0 group. That's the reference group. And if we estimate this fully interactive model, then alpha 2 is a direct test on whether this treatment effect for the high is 1 group is statistically significantly different from the treatment effect for the high is 0 group. Is alpha 1 actually different from alpha 1 plus alpha 2? This is what this estimation equation is going to tell us. It also says in so many words in Alcott's 2011 paper, in which he says, I show that conditional average treatment effects are larger than 6% in the highest decile of pre-treatment usage and close to 0 in the lowest decile. So major difference in the treatment effect between subgroups. Now, there's actually also an alternative way of estimating this model, and I'm going to show it to you because both models are used in the literature, so you should be familiar with both models. And actually, you may want to use this alternative model yourself too. It's just a matter of taste, really, which one you are going to use. Now, how does that look like? As follows. In this case, the estimation equation is actually alpha 1 times t times 1 minus high. So basically, the high is 0 group plus alpha 4 times t times high. And in this case, we get the treatment effect for the reference group, alpha 1, and we also directly estimate the treatment effect for the high is 1 group. So that's different, right, from the previous specification where we actually estimate the difference between the two gates, the two conditional average treatment effects. And here we separately estimate the two conditional average treatment effects. Do note actually that the standard errors may also differ between alpha 1 and alpha 4. And very importantly, if you do see that alpha 1 is different from alpha 4, then to be able to conclude whether this difference is meaningful, you have to conduct a separate test, and then only then you can see whether you can reject whether the difference between alpha 1 and alpha 4 is 0.